Okay, we've got some decimals, some fractions all mixed up here. 5.5, subtract, in parentheses, 1/2 minus 1/5. Just simplify by using the order of operations. And we do have more than one operation, so we have to do that. Okay, PEMDAS says parentheses first. So we go inside here and figure out what that is. Now that requires an LCD. For 2 and 5, that would be 10. So we want to convert to tens. So if we go from a 2 to a 10, we'd have to multiply by 5. And therefore the top has to get multiplied by the same thing. Likewise here, this is tenths, but the multiplier here is 2. So the top gets multiplied by 2 to give us a 2. All right, so we've got 5 tenths, take away 2 tenths. Now, technically, we should do this. We should put it over 10, and then write it as 5 minus 2. And then we say, I'm sorry, I don't subtract numbers anymore. I do the addition of the opposite. So technically, we do have to go to rule number 2 for addition, which is opposite signs. Subtract smaller absolute value from larger and attach the sign of multiple larger. But, we have memorized subtraction tables. So therefore, it's much quicker. And it's 3/10. All right, so what do we have now? Going back to the original, 5.5, subtract 3/10. Okay, now we're lucky because we ended up with tenths. That was the LCD, so we ended up with tenths, and that's a decimal fraction. So it's very easy to write down. And we can convert everything to decimals very simply. This is 0.3. Okay, now again, technically, we should be doing addition of the opposite. But that takes so long that it's almost not worth doing. If you're doing this on the calculator, of course, you press your subtraction button. But at any rate, you end up, if you're going to stick to the rules here, it would be addition of a minus 0.3, subtract smaller absolute value from larger, so you end up doing exactly the same thing. And it becomes 5.2. And you attach the sign of the one with the larger, which is positive, so the whole thing is 5.2. This is an exercise in showing you how to convert to the LCD before you do the subtraction. And then luckily we could get everything in decimal form pretty easily.
Good afternoon, everyone.
It's almost good evening. All right. Any other questions? 10.3. We're given some low temperatures for Anchorage, Alaska. -4 and -8 and 0 and 3 and -8, -1 and 2. And what they're asking us for is the range of these low temperatures. Now the definition of range is right above that, and that is highest minus lowest. And that's range. Okay, so the highest temperature isn't terribly high. It's 3. That's the most positive of these numbers. It's farthest to the right, so to speak. So that's what goes in here. And subtraction is part of the definition of range, to subtract. And the lowest temperature, well, that's going to be the -8. It occurred twice. So it's minus on -8. So basically what they're trying to show you is there really does happen in real life a reason to use minus a minus that really exists. We change it immediately to addition of the opposite. Now this is where we should use the rule because it's important to get it correct. And the opposite of minus 8 is a plus 8. So all that comes out to be 11. So the range of temperatures is 11 degrees. It starts at 3 below 0, I'm sorry, 3 above 0, and goes all the way down to 8 below 0. That's an 11-degree difference. So it makes sense. Any others?
93.
93. The height of Mount Everest is 29,029 feet. Sometimes it does change. The lowest point on the surface of the Earth is minus 35,798 feet. That is below sea level, occurring in the Mariana Trench. That's not actually the lowest. They found a lower one now. What is the difference in altitude between the height of Everest and the Mariana Trench? Same basic idea. It's very much like range. So you want to take the highest, subtract the lowest. So you're doing this. It's going to be 29,029. That's Everest. Subtract the 35,000. Now that's a minus 35,798. And again, it becomes minus a minus, so it becomes plus a plus. You end up adding these two numbers together. And that's 17, 10, 12, 8, 14, and 6. 67,827 feet. 64,000, excuse me. Okay. Who else came in here? I'm giving back the labs. Anyone I owe a lab to? That's the one. Okay. Another one? Okay, good. Any questions?
One question. When two are the same, the two, the number, two the same, that's why they come. Not worried about the middle part, the three, because it's two negative, it's two positive.
It's number 113. Okay. It says subtract the real numbers by using a calculator. So, what was your question?
Why is it positive?
Why is it positive? Oh, okay. Okay, it looks like this. This is supposed to be done in the calculator. And it looks like this. All right, a minus 23.24 subtract a minus 90.01. Well, if we use the rules which we've developed, which is we don't do subtraction, then this one remains what it is, minus 23.24, but this becomes plus a plus, basically. Changes to addition of the opposite. Now, this is going to be the dominant number, because it's much bigger. So therefore, when you add these two things together, using rule number 2 for addition, you subtract the smaller absolute value from the larger, so you'll have more positive than you have negative, so the end result is positive. And my book says that the end result comes out to be 66.77. But the calculator has all that built in. It knows about subtracting and adding negatives and positives. That's all built into it. You don't have to tell it anything about that. You just enter it in exactly the way you see it right there. It looks like this. Depending on your calculator, you might have to put the number in first and then put a change sign button. I'll write that as CHS. And then subtraction. And then again, 90.01 change sign. And then equals. That should give you 66.77 because all these rules are programmed into the machine. Actually, the reason why some calculators cost more than others is the programming is better. And they're basically little computers. Once in a while, we get calculators, even from the big companies, that don't work correctly. Yeah, it does happen. Okay, any other questions in this homework section? All right. Is there anyone who wasn't here on Friday who would like a laugh? All right. Well, let's go on. We're going to continue with psi numbers now. And our next job is to look at multiplication and division. So let's do that. Now, luckily, of course, multiplication is repeated addition. So since we've covered addition, that's all ready to go. In other words, if we're talking about something like 2 times 7, then we know from the definition of what multiplication is, this is actually 7 added to itself twice, 2 times. And we have the rules for addition. That would be rule number 1, because they're both positives. You add the two absolute values, yada, yada. So the whole thing comes out to be 14. So what we notice is that when you're multiplying two positives, you end up with a positive. Okay. Strangely enough, we can even use that when we're talking about negatives. Suppose we have 2 times a minus 3. Well, according to our basic definition, we'd have to interpret it as minus 3 added to itself 2 times. It wouldn't make sense to take 2 and add it to itself minus 3 times, because that doesn't make any sense. So we'll interpret it this way. Minus 3 added to itself 2 times. Now we know, again, the rules for addition tell us that that's going to be a minus 6. And so we have the idea that a positive times a negative is negative. Okay. Now the only one that really provides any trouble at all is what happens when you multiply two negatives. And unfortunately, there's no nice way to interpret that in terms of addition so that we can get it right away. We've got to go to around the barn to get this one. So we're going to do something called patterning. So we'll start off with something like 3 times 4. Of course, we know that's 4 3s added together, or 3 4s, either one. It's 12. Okay, let's take 3 times a minus 4. Well, according to what we've just done, that had better be a minus 12. Okay, now what I'm going to do with this one is lower that left-hand factor by 1 and see what happens to the product over here. So this is going to go down to 2 times a minus 4. Well, that would be minus 4 added to itself twice. Again, we can do that because of our rules for addition. That's minus 8. And 1 times minus 4. Obviously, that's going to be minus 4. So what's happening here? I'm taking this factor right here, and I'm decreasing by 1. And I'm looking at the product over here, and that's increasing by 4. Why is it increasing? Because you're going from a minus 12 up to a minus 8. Think of the temperature scale, huh? You're down at minus 12 degrees, you're coming up to a minus 8 degrees. It just got warmer. It's more positive. And likewise, minus 8 goes up to minus 4 degrees. Now, 0 times anything, we've already said, is always 0. But notice it does come up by 4 degrees there. It goes from minus 4 up to 0. So it keeps the pattern going. Now the crucial one happens. I'm going to reduce this by 1 again. Minus 1 times minus 4. This is the thing we can't really interpret in terms of addition. It doesn't make sense. But if the pattern goes on, this should go up by 4 degrees. Is it 0? It should go up to 4. And mathematicians are very nitpicky people. They don't want their patterns broken. Huh? So this pattern needs to continue. Likewise, this would be a minus 2 times a minus 4. That better go up by 4 degrees to a positive 8, and so forth. Minus 3 times a minus 4 better go up to a positive 12. In other words, we keep that going all the way down. Which tells us that this strange combination of a negative times a negative has to be a positive. It's, I would say, counterintuitive, but in order for multiplication to work, let's put it that way, then you gotta have a negative times a negative as a positive. So let's look at a few examples of that. It's very simple when you get used to it, nothing complicated. Basically what happens is this, is suppose you have two numbers, they're both negative, they're being multiplied together. First of all, the easiest thing to do is take care of the sign. Minus times a minus, plus. 8 times 7, 56. And that's it. It's usually done in the head. There's no particular writing that you need to do for it. So a minus 3.1 times a minus 4.6, that's going to be positive. Once you say, look, the result's got to be positive, you don't worry about it anymore. And you just do a normal multiplication, which would be 3.1 times a 4.6. Again, what do we do when we multiply decimals? That was, well, weeks ago. We probably forgot, right? Better not forget. You know what's happening soon. 6 times 1 is 6. 6 times 3 is 18. 4, 12, and so forth. 12, 4, 1. Now, 1 to the right, 1 to the right, 1, 2, 14.26. And that is positive. It's a positive 14.26. Okay, how about something really gnarly like this? 4 sevenths times 5, 5 sixths. Mixed number times a negative fraction. Just going in the kitchen sink now. Okay. Well, again, we have to go back in our memories to figure out, well, how do I multiply mixed numbers? Oh, I don't. Okay. So I convert it to an improper. Right? Is that somewhere in that memory? Yeah. All right, 6 times 5 is 30. 5 is 35 sixths. Okay, times a minus 4 sevenths. Well, a minus times a plus, according to what we have over there, has got to be negative. All right, we take care of the sign. Don't need to bother with it anymore. Now we just multiply what's left the way we usually would. And we can divide, of course, cancel a 7 up here and up there. 2 goes into this 3, goes into that 2. So we get a 10 on the top and a 3 on the bottom. That's minus 10/3. In this case, because they started with a mixed, you might want to write that as a mixed also. Chances are the answer in the book would be mixed. So I'm sure you know how to do that. I won't bore you with that. All right, let's do another one. Minus 12 times minus 7/3. Now again, the fact that we have one whole number there, 12, doesn't really change much because we can always think of that as a fraction. So we've got 2 negative fractions multiplied. We know that's got to be positive. We do get some canceling. So we get a 4 times 7 is a 28. There's the answer, 28. Turns out to be a whole number. So this is how you deal with negatives and positives in multiplication. Rules are the ones we had there just a moment ago. Let's just write them down in one place so we can get all our rules together. Okay, rules for multiplication of sign numbers. Okay, positive times a positive equals a positive. Positive times a negative equals a negative. A negative times a positive equals a negative. A negative times a negative equals a positive. Actually, you can write them down as 2 rules if you want to. You can say, when I've got the same signs, the result is always, the product is always positive. When I've got different signs, the result is always negative. So that's multiplication. And you do some of these, and it's a very natural kind of thing. Doesn't stress anybody out too much. All right, there are situations that arise, especially in algebra, where you're multiplying, let's say, a negative number times itself quite a few times. Repeated multiplication. Now, repeated multiplication is, the abbreviation for that is exponent. But right now, we'll just take a look at what happens with repeated negative multiplication so you get a feeling for it. So you start out with something like -2 times -2. That's simply a repetition twice of a negative. We already said that's got to be a positive 4. All right, let's take it to the next stage and see what happens. Now 3 minus 2's multiplied together. Well, the reasoning goes this way. You know that these two multiply to a positive. So a positive times a negative has got to be negative. And of course, the 2 times 2 times 2 is 8. And then let's keep on going. We'll do one more so you can see what happens. There is a pattern forming here. These two multiplied together are positive. These two multiplied together are positive. And these two multiplied together are positive. So this whole thing's positive, and it's 16. All right, the pattern looks like this. It's a relationship between the number of negatives you're multiplying together and whether that number is even or odd. So if you start out with an even number like this, you know, the result's positive. Odd number, I'll just write even up here. These 3, that's an odd number, that's 3 of them, and the result is negative. Happens down here too. This is even. Result, positive. And if we went on to the next one, multiply 5 of them together again, we come out with a negative, it'd be a negative 42. So it flips back and forth between even and odd numbers of products. If you throw a mix in there, you still use this idea, because you only take into consideration the number of negatives you've got in the mix. Suppose you have a -4 times a 2 times a -1 times a 5. Okay. Well, you know that multiplying by positives basically doesn't do a whole lot. I mean, you could do it this way. You could say, look, I've got 2 negatives. Multiplication's completely commutative, so I can do this kind of thing. I can get the -4 next to the -1. The 2 out here, the 5 out here, and then I can even put the 2 and the 5 together. It's just keep commuting them. Let's just put it together. These 2 multiply to a positive. Of course, everything else is positive, so that's not going to change anything. So the result has to be positive. Bottom line is you simply look for the number of negatives in a product like this. If it's even, the whole thing's positive. If it's odd, the whole thing's negative. Okay, now let's go to the exponential notation for this, because that's what you use in algebra. It's the same thing, it's just got a different notation. So if we took, let's say, a -3, raised it to the 4th power, we are talking about a -3 times itself 4 times. So this is repeated multiplication. And from what we've just said, positive here, positive there, 2 positives multiplied, it's got to be positive. So this has got to be a positive, and this is an 81. Now we don't write the positive sign, but it's there. Now notice the problem with this exponential notation. What's that? Well, it's the same thing without parentheses. But the parentheses are used in exponential notation to define the base. And since there are no parentheses around the -3, you have to assume that the base is only the 3, not the negative sign. I will say that again, okay? In exponential notation, the base is whatever is immediately to the left of the exponent. The exponent is 4. What's immediately to the left is the 3, not the negative sign. That's not immediately to the left. So without the parentheses, this means the opposite of 3 times 3 times 3 times 3, which is a -81. It's a different number. That's math.
Whoever came up with that.
You can moan and groan about that, but you're not going to change mathematicians. That's the way it is. So these two things are quite different from each other. One's 81, one's -81. We have to live with that.
Yeah, that makes no sense.
Let's look at a few others, just compare some things. This problem actually only occurs when you're talking about even powers. When you're talking about odd powers, you don't have the problem. But they happen enough so that you need to know it. For example, -5 raised to the 3rd power is 3 -5s multiplied by each other, which we know is these two multiplied to a positive, and then times another negative gives you a negative. And 5 times 5 is 25, times 5 is 125. Now let's do it this way, -5 cubed, where the 3 only now applies to the 5, the minus sign means opposite. Okay, that gives you the opposite of 5 times 5 times 5 is 125. Oh, no difference. Odd powers is no difference. The only problem occurs when you're talking about even powers like 4s and 6s and 8s and stuff like that. Then the parentheses make a big difference. Is he going to put that thing on the test? Yeah. Even worse, he can put
Now,
stuff like
I
this
have a
on the test.
question. When you have like 5,
With the camera
-5,
down, you could probably see it better.
-5,
Yeah.
it doesn't matter where you start? I mean, if you want to start, oh, but yes, it does. Never mind, I answered my own question.
Okay. All right. So what do we do with this thing? We do it carefully, okay, step by step. Because actually what you're being asked for there is two things. You have to take two ideas and put them together. The first one has to do with raising to a power. Now, you do have parentheses, so the base for that squaring process is the entire thing, it's -4. So this really means the opposite of a -4 times a -4. Because the minus sign is inside the parentheses, so it's included in the base. Okay, so that's going to be the opposite of, well, these two multiply to a positive 16. And the opposite of a positive 16 is the number -16. So all that comes out to be a -16. Exponential notation. Here's another thing about bases. Suppose your base is a fraction like that. Once again, because of the use of parentheses, it tells you what's included in the thing you're going to multiply times itself 4 times. It's the entire thing with the minus sign. So this means -1/2 times itself 4 times. Now, how do we multiply fractions? Well, first of all, minus times minus is a plus, minus times minus is a plus, 2 pluses, plus. Forget the signs now, just drop them. And you multiply tops, you multiply bottoms. You get a 1 on the top, 4 here, times 4, 16. So that's what that is. All right. Let's see if there's any of the sneaky ones here. I don't think so. All right, let's go on to division of real numbers. Before we do division, let's talk about reciprocals. Now, we've talked about reciprocals before, but want to review it for just a moment. Reciprocal of a number, let's call it A. Well, let's give it a different letter here. Let's call it N. Is the number which, when multiplied by the original, gives a product of 1. That's a very long definition, but in the regular process of doing math, it's very simple. So if you take something like 5, and you're looking for a number to multiply that by so that the product is 1. Well, just from the laws of multiplication that we just did, that's a positive 5. So what do you have to multiply a positive by to get a positive? A positive, right. So the reciprocal has got to be 1 over 5, because then the 5s will cancel, and you get a positive 1. But if you're talking about the number minus 5, okay, we still want to end up with a positive 1. And we've already got a factor that's negative. So the only way to get this multiplication to come out to be positive is for that to be negative. So the reciprocal has to become negative then. It's a minus 1/5. Plus, minus times a minus is a plus, and 5's cancel again, you get 1. Right? So reciprocals are the same sign as the original number, but of course 1 over. If you're dealing with fractions, it looks like this. Suppose you have a 2/3, and you want to multiply it by its reciprocal to get 1. You simply flip the fraction over, and this one happens to be positive, so this is going to be a 3/2. And then the 3's cancel, the 2's cancel, and there's the 1. If you had, let's say, a minus 4/5, its reciprocal, again, to get a positive 1 would have to be a minus 5/4. Minus times a minus, plus, canceling, cancel. Okay, now given that idea of reciprocal and the fact that we gave up doing division a long time ago, we changed it all to multiplication by the reciprocal. We actually are set up to do division of sign numbers. Okay, so if we start out with a positive 12, and we want to, let's say, divide it by 7, we say, sorry, I don't do that. I do positive 12 times. Take that 7, think of it as 7 over 1, flip it over, 1/7. And again, positive times a positive gives you 12 sevens. If you wish, you can convert that into a mixed 1 and 5 sevens. But if you start working with negative numbers, let's say something like this. 50 divided by a negative 5. Well, let's see what happens. Let's go into our insistence that we're not going to do division. This is 50 times. Now, negative 5 is negative 5 over 1. Flip it over. That's going to be negative 1 over 5. Positive times a negative is a negative. 5 goes into that 10 times. It's negative 10. Negative 10. We're going to start getting some rules going here also. Plus divided by a plus, plus. Plus divided by a minus, minus. Let's start out with, let's say, a minus 4, and we want to divide that by a 2. Okay, far as we're concerned, we only deal with the second one. Make multiplication by the reciprocal of that, 1/2. Minus times a plus, minus 2 into 4, 2. So here we have a minus divided by a plus, and we still get a minus. And then finally, we've got to do the double negative one. Doesn't matter, let's just use some numbers. Suppose we have a minus 20 divided by a minus 10. Okay, we turn that into minus 20 times 1 over minus 10, which you can write as minus 1/10. And again, negative times a negative, positive. 10 to 20, 2. So a negative divided by a negative is a positive. Now, if you go back just a few minutes ago on Lewis's camera, you can find out there's a photo there with the rules for multiplication, right? These are identical. There's no difference at all. This is exactly the same rules we had for multiplication. If you're dividing two positive signs, you always end up with positive. If you're dividing two negative signs, you always end up with a positive. Same thing. The only time you end up with a negative is when you're mixing things up. When you've got one thing that you're dividing that's positive and the other part is negative, in either direction, positive, negative, or negative, positive, then it comes out to be negative. Identical rules for division and multiplication. Why? Because we changed division into multiplication, so of course we're going to use the sign rules for multiplication to calculate division. You know, so it's got to be the same. Okay, let's do some examples of that. All right, let's put it in the normal notation for fractions. Minus 42 divided by a minus 7.
You get call medical?
Oh, what's going on? Someone use the phone?
911.
You okay?
Call 911.
Good, okay.
Oh, I got some
I
water
got
here.
water.
She's got a boss. Being.
And if you look at her arm, it looks like she has some blood
Oh,
drops.
you gave blood.
Yeah.
Mm.
That's what. Yeah.
Oh, she needs to have something to eat. Give her some, anyone got a sick kid?
Orange.
I have some. Need sugar.
Some kind of candy or something with sugar. Need to get her blood sugar.
I have this, the fruit chew. That's sugar.
My car's all the way over there.
Usually when you go to get blood over there, they give you these carrot juice afterwards.
Yeah.
Very heavy carbs and sugar. So that won't happen.
It doesn't come from how it is. Yeah. No.
Keep an eye on her. All right, let's go back over here. Minus 42 over minus 7. The way we handle this is very simple. Minus divided by a minus, that's same signs. Same signs, positive. 7 into 42, 6. That's it. Yeah, it's a very quick process. All right, let's do some fractions with it. 4/15 divided by a minus 8/25. Handle the signs first. Positive divided by negative, negative. It's going to be negative. We know it. Okay. Sorry we don't do this. We do the following. Leave this one alone. Multiply. Flip that over. Cancel, of course. Once, twice, 3, 5. It's going to be a negative, and what do we have here? 5 on the top and 6 on the bottom. That's it. Very simple, very direct. There are just a couple other things to remind you of about division. They're on page 614. Let's do an example of it. If you have something like 0 divided by -7, don't get confused by this. That means you came to school with nothing in your pockets, right? 0. And it doesn't matter how many friends come to borrow something, they all get 0.
Zero.
Okay, so when you're splitting a 0 up into some number of pieces, it's 0. Okay, and even if that's a negative down there, it's still 0, because 0 doesn't actually have a sign connected with it. So it's a different case. The one that you have to watch out for is this. That's the one that is not allowed. That's called undefined in mathematics.
Why?
If you allow that to happen,
We get error.
all of mathematics falls apart.
Part.
Yeah. That means you can prove that any number is equal to any other number. And I'm sorry, that won't work in mathematics. Did you call?
Yes,
Lydia,
the
you-
nurse is coming.
See, they're coming? Okay.
Hi. Is it okay? Okay.
Good.
Yeah.
All right, I'll put the homework on the board, and we'll look at it tomorrow.
Next time, you could put it down and press it up.
Yeah.
Have you eaten today?
We just gave her some.
And 911 was called?
Yes. She said to come to the hospital. You want to go outside or do you want to see her?
Yeah. Is there a throw up?
Yeah, she feels like it. Right here, right here. Sorry.
All right, we have,
Think twice about giving blood. Okay, Diego? David? Marley? Okay, that's it. Okay, that's it. See you tomorrow.
Yeah.